Hi, this video is going to continue with the accuracy and tolerancing, only this time we're going to be using a volt ohm meter, a VOM. Calculating the accuracy and the tolerance on a VOM is somewhat different than on a digital multimeter, only in the way we find the tolerance. So I decided that what I would do is use a Triplet VOM, and Triplet is a company that's been around for a very long time, and they're kind of the workhorse of the industry. Triplet and Simpson are probably one of the better volt ohm meters. Of course, that's my opinion. So I need to get some specifications on one of the Triplet volt ohm meters. So I'll go to the internet, I'll open my web browser, and what I'm going to do is do a search for Triplet VOM. So I just clicked into the URL bar and I'm going to type in there Triplet VOM. And I can see already that there's a model 310, but I don't know what model, I don't remember what model it is. So I'm going to just go to the Triplet meter, or VOM, and the Google search page opens. I can see that I've got an ad here, and just like I did for the digital multimeter, I'm looking for the manufacturer's website. That's where you're going to get the most accurate information. So I'm looking for the Triplet website. So here's specs, manuals, and so this is an ad. Specs, manuals, and software, Triplet, and that's triplet.com. Here's a model 630, 330 test equipment. That's at Triplet. There are two different websites. Let's see, sound level calibrator. That's probably not what I want. The model 630, product number 330. This is a classic VOM 25 range. Let's do this one. I don't want eBay. So I'm going to go to Triplet and I'm going to right click, open link in a new tab. And here is a picture of the model 630. And I can look and see if I have any specifications on here. I see it's 25 ranges. And I look down through the product descriptions, and there's a lot of information here, but it's not what I'm looking for. 25 ranges and functions. It's giving me the frequency range of AC. It's not giving me any tolerancing or any accuracy specs. Say these are the categories in the catalog. Let's see what's under related. There's some product videos. But I see product manuals and software. That's where I'm going to go first. I'm going to right click, open link in a new tab, and Triplet, it looks like, has their meters and all of their products listed. So now we're going to have to find a Triplet and the 630. So let's see. They're not digitals, they're not digital clamp-ons. VOMs are older instruments, so maybe it's under legacy. But I also see analog voltmeters down here, and they list the 630 PN3030, but I'm not sure about that PN3030. So I'm going to look over here. Volt ohm meter, that's not a 630. This is an MDL 630. I doubt if that's it. That's an NS. This is a PL. Just going to keep looking down. MDL 800. These are not VOMs. These are not VOMs. Classic VOM 58 ranges. The one we had was 25 ranges. Classic VOM 28. That's not it. Even though it's a 630, it's not the right one. Electronic volt ohm meter, nope. Let's keep going down the list. I still don't see it. Down the list, down the list. A lot of digital multimeters. 630 manual, that could be it. Let's see, it's not cable sets, it's not anything here. Calibration set, other resources. I'm going to try that 630 manual. So the 630 manual, I'm going to right click and open that in a new tab. And it looks like this is the model 630. And that certainly does look like the one on the website. So I'm going to scroll down this document, and it looks like specifications. Let me zoom in. Specifications are on page 4. And yes, they are. Here's the specifications. So I have DC voltage. It shows me the ranges, the accuracy, the sensitivity, maximum input voltage for AC voltage, DC current, ohms, decibels, battery, test leads. So let's go back up here, and we did, for the digital multimeter, we did DC voltage. This time let's do AC voltage. And we're going to measure the same voltage at 48 volts, only this time it's going to be AC. Take a look at the meter. We have some ranges. We have 0 to 3, we have a 12 volt range, a 60 volt range, 300, 600, and the accuracy is plus or minus 3% of full scale reading. This calibration information we don't really need for what we're doing in this lab. So plus or minus 3% of full scale, that's important. And we're going to be measuring 48 volts, so that means we're going to be on the 60 volt scale. So let's go over to my pad, and we're going to be using a model 630, and we're going to measure 48 volts AC, and we already know that that's going to be on the 60 volt range. So the specifications for AC voltage are plus or minus 3% of full scale, and FS is an abbreviation for full scale. Now, on analog meters, the meter is the most accurate at full scale. So if I have a meter with this being 0 volts, this being the 60 volts, or the 60 mark, this is where the meter is going to be the most accurate. So, and we're going to be using the 60 volt scale. So to find the tolerance of the reading at 48 volts, that's the voltage that we're measuring, I need to know what it is at 60. So let's take a look at this scale a minute. There's 60. 30 volts is going to be about mid-scale. And then, let's see, 40 is going to be here, 50 is going to be here, which means that 48 is going to be somewhere in here. So let's do it at 60, because again, we are going to be doing full scale. It's 3% of full scale. So the full scale is 60, and I volts AC, and I need to multiply that by 3%. Well, 3% is 0.03. We could do it just like we did it at for the digital multimeters, where I could take 60 times 3 divided by 100, which is going to be 60 times the 0.03. So let's bring up the calculator and do that calculation. So that's 60 times 0.03 equals 1.8. So that means that the the voltage down here is going to be equal to if I can find my pen, is going to be equal to plus or minus 1.8. So that means that 60 volts plus or minus 1.8 volts. So at 60 volts minus 1.8 is going to equal 58.2, and at 60 volts minus or plus 1.8 is going to equal 61.8. So my tolerance at 60 volts is 58.2 to 61.8. But this 1.8 volts right here, this 1.8, this tolerance follows through for any reading I make on this scale. So at 48 volts, I'm also going to be plus or minus 1.8. So let me go to the next page. So here at 48 volts AC, I'm going to be plus or minus 1.8 volts. So 48 minus 1.8 is going to be equal to, and 48 plus 1.8 is going to be equal to. So 48 minus 1.8 is going to be 46.2, and 48 plus 1.8 is 49.8. So my range for this particular meter on that 60 volt range measuring 48 volts is 46.2 to 49.8 volts AC. All right, now that we have the tolerance at 48 volts, or when I'm measuring 48 volts, we know that it's plus or minus 3% of full scale. What is actually the percent error in my reading on that 60 volt scale when I'm measuring 48 volts? Well, that can actually be also calculated. So let's do the calculation for this. To do that, if you think about what we did, we had the 48 volts and we multiplied it by the percent tolerance, and that was equal to the tolerance. Well, we know that that's 48 volts. We do not know the percentage, but we know our tolerance is 1.8 volts. So this is some simple algebra now in order to perform this, to find the percentage. And remember, percentage was divided by 100. So in order to solve this, I want to get the percent on one side of this equality. So in order to get this 48 gone, the inverse of multiplication is division. So if I divide both sides of this equality by 48, the 48 will go away from this side and leave me with the percent over 100 is equal to 1.8 divided by 48. But I still have this 100 over here, and I want percent all by itself. So to get rid of this 100, I'm dividing on this side. I'll do the inverse. So if I multiply both sides of the equality by 100, it'll get rid of this 100. So when I multiply both sides, I'll have percent is equal to 1.8 over 48 times 100. So let's rewrite this. I'm going to rewrite this on the next page. So then what I have is percent is going to equal 1.8 over 48 times 100. So let's do the math. So 1.8 divided by 48 equals, and then times 100 equals 3.75%. So this is percent is equal to 3.75. Notice it's not 3% anymore. At 48 volts, my accuracy is now only 3.75%. So what do you think would happen if I was measuring 10 volts? Well, if I'm measuring 10 volts AC on the 60 volt scale, I still have to apply the 1.8 volts. So it would be 10 minus 1.8, which is 8.2, and it would be 10 plus 1.8, which is equal to 11.8. So it's 8.2 volts to 11.8 volts. I can see already that that is a huge difference from what 3% is going to be. Let's figure it out. So our percent is actually going to be equal to the 1.8 divided by 10, because I'm measuring 10 volts, times 100. And let's see what that comes out to. So 1.8 divided by 10 equals that, times 100 equals 18. So at 10 volts, it's 18%. So when measuring 10 volts AC on the 60 volt scale, it's plus or minus 18%. That's a fairly large error. So whenever error is measured in plus or minus percent of full scale, the closer to full scale the reading you're taking becomes, the more accurate it gets. The lower down on the scale, the less accurate it gets. So I hope that helped you with VOM accuracy and tolerancing.